Hello guys, this is Amritpal Singh. Today I'm here to present a video on the topic MLLib data types. In earlier videos we have talked about the basics of Apache Spark and Scala. Today we're gonna discuss about what are different data types available in MLLib or which is supported by Apache Spark as far as MLLib is concerned. You can see on the screen there's one diagram shown on the screen that if I talk about the Apache Spark MLLib, which is short form or form for the machine learning library. Okay, we got four different types available. First is local vector, labeled point, local matrix, and distributed matrix, which is further classified into more categories. Right. Today we'll discuss these categories in more detail, that how we can implement those in the Apache Spark and what's its meaning. Okay. So you can see that local vector is further classified into dense and sparse, local matrix into dense and sparse, distributed matrix into row matrix, index row, coordinate, and block matrix. So we'll discuss one by one. Let's start with the basics first, right? So first thing is local vector. So the MLLib supports local vector and matrices stored on a single machine, as well as distributed matrices backed by one or more RDDs. I hope you all are aware of the term RDDs, which are nothing but resilient distributed data sets. So what it's meaning that MLLib supports both local vectors and matrices on single machine, as well as the data. It also supports the distributed matrices, which is separated or which is distributed among multiple RDDs, right? A local vector has an integer typed and zero base indices and double typed values stored on a single machine. So what is the meaning of indices here? So for that I have taken one example here. Let's suppose these are my numbers 51363272313. I need to find the indices for value 3. It will be 0. For example, this will be having 0th indices. This is first, this is second, and this is third. So 0 1 2 3. This is the indices for value 3, right? I hope it is clear. So local vector includes two subtypes, dense vector and sparse vector. So what is the meaning of dense? Dense is nothing but compact, and sparse is which we can say that we usually say with respect to the term population, that this region has a sparse population. Means at some places we are having some people are living over there, and some places there's no population available at all. So in the terms of MLLib, a sparse vector is a vector which contain more elements are 0 1, and dense which are more of non-zero, right? So we'll see with the help of one example that how we can create those vectors, right? Let's move ahead. So what is dense vector? First of all, by definition, dense vector means closely compacted. Okay, as I've already stated, right? So dense vector is the one that contain many values, or the values that are non-zeros. One of the best examples are NumPy arrays and Python list are recognized by MLLib as a dense vectors. So these are the examples of dense vectors. We'll see in with the help of practical example that how we can create dense vector in a while. Next is, what is sparse vector? So by contrast, sparse vectors are backed by two parallel arrays. These arrays represent vector indices and its values. We already have seen the meaning of indices. So we can say the sparse means thinly dispersed or scattered, or that I've already stated. In this case, you'll get the data in a scattered fashion. Okay, so the majority of the values in the sparse vector will be zeros, as against the dense, where we got more of non-zero values. So MLLib recognizes MLLib's sparse vector type vectors, okay, and SkyPy's CSC underscore matrices. Okay, so let's start that how we can create those, right? For your understanding, I have taken one snapshot here. Okay, what's the meaning of this dense and sparse, right? We often write dense vector in this form 1 0 5 0, right? This is a dense vector form. Okay, in order to optimize the one, we can make use of sparse vector, in which we use this notation for square bracket 0 2 1 square bracket 1 comma 5.4. What is its meaning, right? So first of all, how we can create it? This is the first point. that we can create, first of all we need to import the library. Okay, let's do it one by one, right? I've already opened my Spark shell, right? So let's first import the library, press enter. Okay, we have imported the library for vectors. Next thing is I need to create a dense vector, for which I'm making use of vector dot dense method. So what it says, val immutable dv is a variable vector, okay, it's data type. So vector dot dense is a keyword. Here I'm passing a values 1050. So one way is to store 1050 is with the help of dense fashion, enter. Another way to store these values 1050, I'm having another method available in which I'm making use of sparse notation, which is the optimized one, right? What it's meaning, you can see from a diagram itself. First number indicates the size. It means, it says that that sparse vector will store the 4 values, right? So first is 0. 0 means 0th indices you will find the value 1, and the second indices you will find the value 5.4. This is the complete meaning. I'm repeating, first value is 4, which means size of the vector will be 4. Okay, 0 meaning is that at 0 indices you will find the first thing, which is nothing but 1. Okay, 1.0. And the second indices, because the vectors are 0th indices, means it starts from 0 as an index location. 0, 1, 2, 3. At 0th place you will find 1, at second place you will find 5.4. This is how we can represent the same dense vector in the sparse form, which is a more optimized way to represent it for representation. So how to create? With the help of vectors dot sparse. Let's create it, enter. Okay, fine. So what I did is, actually in both the examples I'm storing the same information but in different way. First in the form of dense, in a more compact way. Next is with the shortcut way, right, in which I'm just specifying the first argument was the size, second argument was the indices, and third was the actual data which I wanna store in a vector form, right? So I can also store in this fashion as well with the help of collection sequence, right? The same, another way to do the same thing, enter. In this case what I'm saying is, like 0 again size, at 0th location I'm specifying 1, at second indices index location I'm specifying 5.4. This is how we can make use of vectors. I hope it is clear, right? So this was the first data type of MLLib. Okay, so let's move ahead. Next one, what is labeled point? Labeled point is also a vector but with a label. Actually labeled point we make use of in the case of supervised learning algorithms. Okay, so in this case we pass either 0 or 1. Let's suppose for a binary classification the label 0 indicates negative or 1 indicates the positive. Okay, so we normally use it in the machine learning algorithms. Okay, so you can think of let's suppose I want to make use of this labeled points to classify whether one is a person or not, right? Or we can say one is a male or not, right? So in this case I need for binary classification, so labels can be used. For multi-class classifications, the class indices starting from the 0, 1, 2 and so on, right? So basically the summary of the story is that we use the label points in the supervised learning algorithms just to do some classification. Okay, binary classification mainly. Okay, so how we can create it? Very simple. So we can say in the same thing which I've already stated in the first step, where we created the vectors in both dense and sparse form, but with this vectors I will be passing one or 0 label. Okay, so let's do it. First of all I need to import its libraries. Okay, first paste it here. I got my libraries, okay, of my labeled point. Then I need to make use of two things. One is POSP, means it's a positive, it's negative, because positive means 1, negative means 0. Let's do it. Okay, The thing is, so label point was actually a vector, okay, but with the label which can be either 0 or 1. 0 indicates negative, 1 indicates positive. I hope it is clear as well, right? Very simple. Okay, let's move ahead. Third one, which is my local matrix. The thing is, like local matrix meaning is that, as I already stated, the MLLib actually supports the both local vectors and matrices, okay, which local meaning is it's stored on a local machine. And if I talk about the term distributed, meaning is the data is stored on a multiple RDDs. So what is local matrix? I've stated on the document file. A local matrix has an integer typed row and column indices and double typed values stored on a single machine. It means here we are talking about the data which is stored on a single machine. So like vector, local matrix includes dense matrix and sparse matrix. Means, as we have learned in the case of vectors, which was of two types. Similarly, local matrix is also of two types. So how we can make use of it? First of all, I'll discuss what's the meaning of it, right? First is, like here we can, this is the one example that how we can create the matrix in a dense form. Matrix, okay, matrices is a keyword, dot dense is a keyword. 3 2 means like we are specifying 3 rows 2 columns array, right? 1 3 5 2 4 6. So what the its graphical representation is given here. 3 2 array 1 0 0 1 0 5, okay, which will become my first column because I've specified that I got 2 columns here. 2 4 0 become my second column. So this is the meaning of this line, right? Next one is, in this case, it's a sparse, okay. First of all, I specified again 4 5, again row and column. Then this is my column pointers, okay. Then this is my row indices, and this is my actual data, actual values. So what is the meaning? Let's see. First of all, you can see in the from a diagram itself, this is my row, this is my column, okay. So we got 5 columns and 4 rows, okay. So this indicates my actual data: 1 14 6 2 11 16 12 9. You can see 1 14 6 2 11 16 12 9. What is row indices? What is meaning? 0 means at 0th location you will find the first element, which is my 1. At my third location of the first column you will find the 14. Then 1 means because you can see because in this case, next again we are starting from 1, meaning is at the first index, because I've already stated here we are starting from 0th location, okay. Again at first location you will find the next element, and afterwards again I'm going to the going backwards from 0. At 0th location I'm getting the next element. Again at second location I'm getting the next element followed by, okay, third, okay. Next at the second location, and then at first, okay. This is the meaning, okay. Next one is column pointer, okay. You can see from a diagram, these are my actual values, this is my row indices, okay. I'm specifying that where in the row you'll find the actual element. Next is the index, okay, 0 from 0 to 8, and corresponding to it we got the column pointers as well. This is how we can make use of matrices in the sparse fashion. So let's create it as well. This is my library for it, okay. Let's load that, enter, okay. Next one is I need to create the dense matrix, copy, paste it. Okay, got the answer, right? You can see from the diagram again it was same 1 3 5 2 4 0. You can see in the 2 4 6, right? Okay, 2 4 6. Next one is, it is my sparse matrix. I got my sparse matrix, okay, fine. So this is the meaning of local matrix. And last data type is left now, which is my distributed matrix. I've already stated distributed matrix is nothing but the data is stored on the one or more RDDs in a distributed fashion. So it is of 4 subtypes. One is row matrix, one is of index row matrix, third one is coordinate matrix, and fourth one is block matrix. So what is row matrix? It's a row oriented distributed matrix without a meaningful row indices, or we can say it's a RD of a sequence of vector without row indices. So how we can create this? I'm having one example for this. First of all, I need to just load the libraries, then followed by I need to make use of VAL, any variable rows equal to sc.parallelize, the method we use to create RDD on any collection of Scala. Here I'm using sequence. Inside I'm making use of vector.dense, right? Afterwards I need to pass this rows into this function row matrix to create a row matrix, and with the help of these two lines I can get to know how many rows and column got created. So let's create the row matrix first. First load the library, okay, load it, enter, then just create the RDD. Okay, I got RDD created. Then at last create your row matrix. Okay, now you want to find how many rows and columns are available. For this, just let's do this as well. I got 3 and 4 as a answer. I hope it is clear, right? This is the meaning of the first one, row matrix. Next one is index row matrix. It's also like a row matrix but with the meaningful row indices. In this case, it means I need to make use of row indices as well. I hope you all are clear with the row indices, which I've already stated while stating this one. Row indices is this one. This is my row indices, right? Okay, this one, row indices. Okay, so how we can make use of it? Again, I need to make use of first the header, the library. Okay, this is my library for my indexed row. So it is also same like a row matrix but with the help of the indices. Okay, with the index. This is one difference between the row matrix and the index row matrix. Again, I need to create RDD with the sc.parallelize on a sequence collection of Scala. Again, I got RDD. Yes, fine. So everything is same so far, but I'm just adding the indexed here. Okay, the almost same kind of syntax for creating the index row matrix. So here we have created the index row matrix. Fine, great. The third one is coordinate matrix. So what is coordinate matrix? Okay, the thing is, as far as the coordinate matrix is concerned, actually it should be used when the both dimensions of matrix are huge and the matrix is very sparse. Then we make use of coordinate. Okay, right? So how we can do it? Again, need to make use of its own library. Okay, enter, then I'll create my RDD. Okay, enter, I got my RDD. At last I need to create the coordinate matrix. So the point to remember is, like, we use coordinate matrix, okay, when the dimensions of matrix are quite huge and the matrix is quite sparse, then we make use of it, right? So here we go, we got it, the new coordinate matrix here. Last point is how we can make use of block matrix. So what is block matrix? It just it included the set of matrix block. Okay, or we can say that a block matrix is a distributed matrix backed by the RDD of matrix blocks, where a matrix blocks is a tuple of int matrix, right, where int and int is the index of a block and a matrix is a sub matrix at the given block. Okay, so how we can do the last one? Again, similar kind of syntax. Okay, first load the library. Okay, then create the RDD. Okay, at last create the blocks. Fine. So this is how we can create the block matrix. Okay, I hope it is clear, right? So this is the video which I have created for the MLLib data types. I hope it is clear to everyone, and we have actually discussed all the types. Just quickly summarize it, right? So local vector, we have discussed that we store on a single machine, local machine, right? It is of two type, dense vector and sparse vector. Dense vector is a compact vector, right? And the same information we actually also specify in the sparse fashion. We actually recommend, or we actually want to store in the sparse fashion because it actually take lesser space, right? Because here we just have to specify its um, size, then write a row, and then we have to specify that as indices and the actual value. Then it is next data type we got is labeled point. It is actually nothing but same to the local vector, but with the label. We actually use for the binary classification, where 0 indicates negative and 1 indicates positive. Then next data type we got was a local matrix, right? It is again a kind of similar to the local vector. It's of two type, dense and sparse, right? And we have seen that how we can represent dense and sparse, although this having a same meaning, dense and sparse here as well. And last one is distributed matrix. How it is different from local matrix, that in this case we need to we actually store data in one or more RDDs in a distributed fashion. It is of it's got four subtypes: row matrix, index row matrix, coordinate, and block matrix, right? I hope you have understood the concept of this MLLib data types, and I hope you have also understood that how we can implement it in Spark, right? So if you got any doubt, and if you want to you want more understanding of any other thing which is not understood yet, right? So just comment on the video. Okay, so thanks for watching.